So we've looked at properties of rectangles, rhombuses, and squares. Today we're going to kind of look at the backwards part of that, right? What if they give me some information? How do I prove that it's a rectangle, a rhombus, or a square? So we have a couple kind of general properties if we have things labeled that we can look for, right, to find out if it's one of these things. So all these start with the fact that we have some sort of parallelogram happening, right? So look at the first example, ABCD is a parallelogram, but then there's one more piece of information they tell me, and that's that AC, right, is perpendicular to BD, right? Or the diagonals are perpendicular to each other. When I have that case, I can automatically say that parallelogram is a rhombus. All right, so perpendicular diagonals, we have a rhombus. The other thing we can look at is if I have a diagonal and a rhombus, right? So the second one, I still have a parallelogram, right? Now I have this diagonal happening, and just for ease of naming stuff in a second, we're going to label these as angles 1, 2, 3, and 4, right? And so I see something happening there, right? I see that this diagonal is creating, congruent smaller angles, right? Basically bisecting those angles so that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4, right? So you have a diagonal that's bisecting your opposite angles, right? You also have a rhombus. And now the third type of thing we can look at is if I still have a parallelogram, right? So ABCD is the parallelogram, but now something else is going to happen with the diagonals. All right, so in this case, I look and say, well, if they give me a parallelogram and my diagonals, or in this case, looking at AC, is congruent to BD, then I have a rectangle, right? So if my diagonals are congruent to each other, I have a rectangle. So I have a couple of different types of things that I'll look at for this as far as like, how do I use this information? So the first type of stuff will be, maybe they give me a drawing, right? A drawing of a shape and some information about it, and I want to know, is it a rectangle, a rhombus, a square? Can I conclude that? So in these first set of examples, right, they tell me that I have parallelograms. So even though it's not labeled, because it's telling me they're parallelograms, I'm gonna assume that and use that, right? And so this first one I look at and say, well, they're telling me SO, right? So SO is kind of this red line here, and TP, this blue line, are congruent, right? They're telling me that right here. So those are my diagonals. So if I were to go back and look at that front page, right, I look at it and say, well, I have a parallelogram and I have congruent diagonals. That tells me that this shape has to be a rectangle. All right. So second example here, right, I still have this parallelogram, and I still have something with my two diagonals here, right? My red and my, if I label them as red and blue again, look at that. Well, if I notice, right, I have this right angle here. So again, if I go look at the front, I'm looking at, well, what happens with my diagonals? So go back to that first one. Well, if they're perpendicular to each other, then I know I can say this is a rhombus just by that fact alone. All right. So the other type of thing I can look at is, well, what if they tell me what shape I need it to be, right? So, and they say, well, what value of x is it going to be this shape, right? It looks like maybe our shape, but how do I force it to be that shape that I want? So if I look at like the first one, they give me two sides, right? And they want that we need that to be a rhombus, right? What value of x, if I plug it in, does it make that shape a rhombus? So if we kind of go back to yesterday, we're using properties of rhombuses, and we know that all four sides in a rhombus are congruent. So I can set up an equation here and say, well, now if they're congruent, I know that their measures have to be the same thing. So I'm going to set them equal to each other, right? 3x plus 9. And now I have an equation that I can solve, right? I can say, well, add 1, 8x equals 3x plus 10. Now I can subtract 3x, so 5x equals 10, divided by 5, so x is equal to 2. Okay? Do the same kind of thing as I go forward, right? If you look at the second one, they're giving me information about the diagonals and it being a rectangle. So again, if I kind of go back to what are my properties of a rectangle, I know that the diagonals of a rectangle are going to be congruent, right? So I'm still looking at that kind of same thing. If they're congruent, their measures have to be equal. So I know that 3x minus 5 has to equal x plus 1. And then I work through solving that equation, right? So I subtract x, 2x minus 5 equals 1. Add 5, 2x equals 6. And lastly, right, going to divide by 2, get x is equal to 3. So now I know that when x is 3, that has to be a rectangle. And so the last one we'll look at is I have a diagonal there, and they're telling me that I need it to be a rhombus. So I go back again to my properties and look at, well, what does the diagonal of a rhombus do? Right? Well, the diagonal of a rhombus, we know bisects each angle that it goes through. So remember, bisect means I'm cutting in half, kind of equal parts. Right? So if I have equal parts, I know that the equations, or the expressions here, 2x plus 39 is equal to 6x minus 9. And so again, I'm just going to work to solve that. Right? Subtract 2x, 39 equals 6, not 6x, sorry. 4x minus 9, add 9, so we get 48 is equal to 4x. And then I want to divide by 4. Move this up just a little bit. So if I divide by 4 and divide by 4, x is equal to 12. So when x is 12, I have a rhombus.